Today we will see how to solve an electrical network using Supermesh analysis. Okay, so this is the example we are considering. In this example, we are asked to find the current in the 5 ohm resistor of the network. Okay, so when you observe this network, you can see there are three meshes present in this network, but you can see a current source which is present between common to mesh 2 and mesh 3. Okay, so let me put this, let me assume the currents in all the meshes. Okay, first, so let this be I1, this be I2, and this be I3. Okay, so I1, I2, I3 are the current in these three meshes. Now just see, mesh 2 and mesh 3 have a common current source 2 ampere. Okay, so when you are solving this electrical network using mesh analysis, you will be applying the Kirchhoff's voltage law. What is Kirchhoff's voltage law? It states that the sum of voltages in a closed loop is equal to 0. So here, when you are considering this mesh 2 and mesh 3, there is a current source present there. So it creates difficulty in solving the network using mesh analysis. So in that case, we will go for super mesh analysis. So what is the super mesh analysis? So you can see this 2 ampere is common between mesh 2 and mesh 3. So what we do is we combine this mesh 2 and mesh 3 to form a single mesh bypassing this 2 ampere and 3 ohm resistor. Okay, so now when there is a current source or the current source which is present in this mesh, super mesh, so what we'll be doing is we'll be writing the current equation separately for that current source. Okay, now let us write equation for mesh 1. So we'll be applying KVL to mesh 1. So KVL, when you apply to mesh 1, you will be getting, okay, the current source I have taken like in this direction. So this is plus, this is minus, this is plus, this is minus. Okay, so you can easily write the equation for mesh 1. So 50 minus voltage drop across 10 ohm. So we can see that 10 ohm current I1 and I2 are passing through 10 ohm. So the drop across 10 ohm will be the difference in current I1 and I2 because it is both in opposite direction flowing through 10 ohm. So minus 10 into I1 minus I2. Then you have the other resistance 5 ohm, that is minus 5 into what is the current flowing through this 5 ohm? It is the difference between I1 and I3. So 5 into I1 minus I3. So this is the equation for first mesh. So when you simplify this equation, we'll be getting it as 15I1 minus 10I2 minus 5I3 is equal to 0. This is equation number 1. Now when you just see mesh 2 and mesh 3, there is a common current source 2 ampere. So what we do is this mesh 2 and mesh 3 forms a super mesh, and we have to write the current equation separately for this 2 ampere source. So consider this 2 ampere source. We have I2 and I3 flowing through this. So we can write the equation as I2 minus I3 is equal to 2. That is our equation number 2. Okay. Now what we do? We have to write the equation for the super mesh. Super mesh means the mesh formed by mesh 2 and mesh 3. Removing this 2 ampere source there. So this is the super mesh. I'll just mark this one is our super mesh. Okay. So we will be in the super mesh. This 10 ohm, 2 ohm, 1 ohm and 5 ohm are included in the super mesh. Whereas this 2 ampere and this 3 ohm are not included in that mesh. Okay, now we will be writing equation for the super mesh. So KVL to super mesh, you will get the equation as, so minus 10 into, what is the current flowing through 10 ohm? That is I2 minus I1. I2 minus I1 is the current flowing through 10 ohm. So this is the drop across 10 ohm resistor. Then minus 2 into, what is the current flowing through 2 ohm resistor? It is I2. Okay. Then you have 1 ohm. The current flowing through 1 ohm is I3. Then you have 5 ohm. The current flowing through 5 ohm resistor is I3 minus I1. Okay. So that is equal to 0. Now, when you simplify this equation, you will be getting it as 15I1 plus 12I2 plus 6I3 is equal to 0. This is equation number 3. Now just see, we have three unknowns and three equations. So we can solve these equations to find the unknown quantities I1, I2 and I3. So solving this equation, we will be getting I1 as 20 amperes, I2 as 17.33 amperes, and I3 we got it as 15.33 amperes. What is asked in the question? Find the current in the 5 ohm resistor of the network. So 5 ohm resistor, if you see, observe this network, we can see that through 5 ohm both I1 and I3 is flowing and it is in opposite direction. So current through 5 ohm, I can write it as I5 ohm is equal to I1 minus I3, and we know the values for I1 and I3, that is 20 minus 15.33. Okay, so we'll be getting it as 4.67 amperes. So this is the current flowing through this 5 ohm resistor. Okay, so this is how we solve the problem. We'll be solving one more example. Okay, I'll just draw the circuit here. We have a resistor, then we have another resistor, and one current source is there, it is going down. Then here we have a resistor, then it is in series with a voltage source, battery. Then we have a current source here. Okay, then another resistor here, then one battery here, then we have a resistor here, then a current source here. Okay, let me write the values, that is 2 ohm, 3 ampere, then we have here it is 6 ohm, the values are given, then 4 ohm, and this voltage source is 5 volt. Okay, and this current source is 7 amperes, then this resistor is 8 ohm, then we have a 10 volt battery, then we have 11 ohm resistor here, then we have a 12 ampere source, current source there. Okay, so this is the circuit, and we are asked to find the question is find the current through 8 ohm resistor. Okay, 8 ohm resistor. Now just observe this diagram. You can see that there are 4 closed paths, that means 4 loops are present, 4 meshes are present here. Okay, so what we can do is we can assume the currents in each mesh. So let me assume this as I1. Okay, and this one I2, this current I'm taking it as I3, then this current I'm taking as I4. Okay, so we have 4 currents in all 4 meshes. Then when you observe this mesh 2 and mesh 3, there is a common current source between mesh 2 and mesh 3. So this will create difficulty while solving the problem using mesh analysis. Okay, so what we can do is this mesh 2 and mesh 3 can be combined together to form a super mesh because there is a current source common between these two meshes. Okay, so we will solve. First we will consider this mesh 1. Okay, first we will write the equations for this current because some current values we already know. You just see in the first mesh, the current flowing through first mesh is I1, but it is directly given in the question as 3 ampere. And we know this I1, it is the assumed direction we have taken, it is going up. So, and this 3 ampere is coming down. So, I1 we can write it as minus 3 amperes because it is in the opposite direction. Now we have this fourth mesh, that is the I4. I4 is given, that is I4 is 12 ampere is also given in the question. See, from the diagram we can easily find it. So that is also in the opposite direction. So you can write I4 is equal to minus 12 amperes. Okay. So now as I already told you, this mesh 2 and mesh 3 forms a super mesh because there is a common current source of 7 ampere present between those two meshes. Now what we will be doing for super mesh, this current source we will be writing the current equation. Okay, so we can write that 7 ampere as, you can see I2 and I3 is flowing. Okay, So we can write 7 ampere as I3 minus I2 is equal to 7 amperes. Why it is I3 minus I2 and why not I2 minus I3? You just see here, this is 7 ampere, okay, it is going in this direction. Now I2 is going in the opposite direction, and when you see I3, it is going in the same direction as 7 ampere. So 7 ampere, when it is going like this, I3 is also in the same direction as 7 ampere, so we assume that I3 is larger than I2. Okay, so we are taking it as the difference, we are taking I3 minus I2 because it is in the I3 is of the same polarity as the 7 ampere current. So we took I3 minus I2 is equal to 7 ampere. Now what we do, now we'll be applying the KVL to the super mesh. Where is the super mesh? Super mesh is formed by this mesh 2 and mesh 3. Here you can see in the diagram, I have just marked because this 7 ampere is now not there. We have combined mesh 2 and mesh 3 to form super mesh. Okay, so KVL to super mesh, you have 4 ohm, 6 ohm, then 8 ohm, then this 10 volt and this 5 volt supply. Okay, so writing that one, 5 volt, okay, 5 minus 4 into the current flowing through 4 ohm resistor is I2 minus I1. It is clear from the diagram, I2 minus I1. The current flowing through 6 ohm resistor is I2 alone, so minus 6 I2. So we are just adding the drops, then minus 8 into, what is the current flowing through 8 ohm resistor? It is the difference between I3 and I4. So it is 8 into I3 minus I4. Then we have this 10 volt. We can see when we are moving in the clockwise direction, we are going from negative terminal to the positive terminal of the battery. So there is a potential, right? So we'll be giving a positive sign for that one. So it is plus 10. Then when we move around this mesh, super mesh, you will be coming across this 5 volt battery. So it is like from negative to positive we are moving. Okay, that is we have already taken into consideration. Okay, so that is I have taken already 5, okay, here. So this is equal to 0. So we have written the KVL for super mesh. Now when you simplify this equation, I'll be getting the equation as minus 10I2 minus 8I3 is equal to 93. Okay, so let me name this equation 1, this is equation 2, this is equation 3, and this is equation 4. See, out of this 4 equation, 2 quantities are already known, I1 and I4 is already known, so we need only 2 equations to solve the remaining variables. Okay, so we can solve for I2 and I3 by using this equation and substituting for I1 and I4. Okay, so you'll be getting I2 as, solving this equation, you'll be getting I2 as 8.28 amperes and I3 as a minus 1.28 amperes. And what is asked in the question, find the current through 8 ohm resistor. So what is the current through 8 ohm resistor? If you observe this diagram, you can see that through 8 ohm both I3 and I4 is flowing. So current through 8 ohm is the difference between I3 and I4. So it is I3 minus I4, and we know the value of I3 minus 1.28 and minus of minus 12. So minus 1.28 plus 12 it becomes. So answer becomes 10.72 amperes. Okay, so this is the answer for this question. This is how we can solve the network using mesh analysis in the sense super mesh analysis. Okay, so that's it. Thank you.